Welcome to aminacademy.com. In fluid mechanics, let us discuss about flow through compound pipes. In that, we will discuss first pipes in series. Pipes are said to be in series if they are connected end to end, that is, in continuation with each other, so that the fluid flows in a continuous line without any branching. The volume rate of flow through the pipes in series is the same throughout. That means each and every pipes which are connected, that volume flow is equal. Suppose a pipeline consists of number of pipes of different sizes and lengths are given here. The first pipe is diameter is d1 and L1 is the length and V1 is the velocity of water in that pipe. Like that for second pipe D2, L2, V2 and D3, L3, V3 are respectively for three pipes. Look at this. Here let D1, D2, D3 to be a diameters of the component pipes. L1, L2, L3 are lengths of the component pipes, and V1, V2, V3 are velocities of flow of water through that pipe. Pipes connected in continuation, as in the case, are said to be connected in series. In these arrangements, the rate of discharge Q is the same in all pipes. Ignoring secondary losses, the total loss of head is equal to the sum of friction losses in the individual pipes. Here, let it be HF1, HF2, HF3 be the losses due to friction of head in the individual pipes, and the total loss of head HF is given by HF equal HF1, HF2, HF3, which is connected in series. Here that HF1 is 4FLV squared by D1 2G is a formula, and for the second pipe and for third pipe. Here this considering, that is, we know that Q equal to AV, that is cross sectional area of the pipe, and as well as velocity multiplication, it gives Q, that is the total flow. Consider this Q equal to A1 V1 equal to A2 V2 equal to A3 V3, in that 4 FL1 by D1 V squared by 2G is considered like FL1 Q1 square over 3.0257 D1 square by calculation of 4 divided by 2G, and A is pi by 4D square. By using that one, after simplification, we are getting FL1 Q1 square over 3.0257 D1 square, like for the second pipe, for the third pipe. Here, if the pipe coefficients of the pipes are different, that means here we are considering the frictional coefficient is same everywhere. If the frictional coefficients are different, for that here, if the coefficient of pipes are different, the above equation can be rearranged as F1 L1 by D1 square, F2 L2 by D2 power 5, F3 L3 by D3 power 5 is compounded as FL by D power 5. Here this is called this equivalent pipe corresponding to the given set of pipe in series. That means here we are using this general expression FL over D power 5 is F1 L1 D power 4. D1 power 5 for second pipe, for third pipe is simply you can write like. Now if D1, D2, D3, that is three diameters of those pipes, and L1, L2, L3 are the lengths of those pipes in series connection, let Q be the discharge, HF be the total loss head. Now HF equal, we know that FL1 Q square over 3.0257 D power 5 for the second pipe, or that is third pipe, and generally you can write FL Q square over 3 0.0257 d4. So here in this, and that means we are considering FL1 plus FL2 plus FL3 is generally FL. That means due to these arrangements we can get, because the common factors F and here this F is cut, this F and common factor of this F is cut, as well as Q square, all everywhere Q common, head Q square cuts, and the remaining this coefficients also cut, that is 3.0257 also cut. So it is for a compound pipe 1 over equivalent pipe is we can say it is L by d power 5 equal L1 d1 power 5, L2 d2 power 5, L3 d3 by 5. This is a simple case, and this compound pipe is considered equivalent length. Equivalent length is L here. By using this formula we can find easily the flow and everywhere. The above relation is called Dupuit's equation. Now we will do an example regarding this pipes on in series. Look at this example. The difference in water level in two tanks which are connected by 3 pipes in series of length 300 meter, 170 meter and 210 meter respectively. The diameters are 300 mm, 200 mm, 400 mm respectively. Is 15 mm. This head difference. The difference of water level is 15 meter. Determine the rate of flow of water of this coefficient of friction for each pipe is given. There is 0.005, 0.0052 and 0.0048 respectively. Now considering the minor losses and neglecting the minor losses, we have to consider first the given things. Length of pipes. L1, first pipe, second pipe, third pipe is given. Diameter of those pipes are given. We have considered meters here. Coefficient of friction F1, F2, F3 is given. Considering the minor losses, we are considering the minor losses also. You know the flow equation A1 V1 equal to A2 V2 equal to A3 V3. That means cross-sectional area into velocity of the pipe is for the second pipe, is for the third pipe is equal. Now from that V2 equal, by using this first two relations, that is V2 equal to A1 V1 by A2. So using A1 is pi by 4 d square, here A2 is pi by 4 d2 square, that pi by 4 cut, like by using the values d1 is 0.3 and d2 is 0.2 and squaring this, we have the relation V2 equal V 2.25 V1. Like that V3 we are considering d1 square by d3 square V1. Using the values d1 and d3 we are getting the relation 0.5625 V1. Therefore we are having velocities of the second pipe and third pipes in terms of first pipe. Now head loss, total head loss is, this is 0.5 V1 squared by 2G at entrance. This is the frictional loss 4F1 L1 B1 square and D1 into 2G. Here this is for the first pipe, this is for the second pipe, and this is sudden contraction. Sudden contraction or sudden enlargement. This is the V1 minus V2 by 2G whole square, and this is for the third pipe frictional loss, and this is loss at entrance, loss at entrance. Here loss at entrance and loss at exit here. So 3 pipes total losses considered, which is equivalent to heads, total head loss. Now substituting these values of V1, V2 and V3 in terms of V1, we are getting total loss is 15 meter, is having 0.5 V1 by 2G. Like this we are applying all values and simplifying this big lengthy calculation. We are getting 15 equal V1 square by 2G, we have 0.5, 2.20 plus 2.53, 89.505, and last one is we are using calculators to calculate those values. V1 square by 2G into this, which is equal to V square by cross multiplying, we are getting 15 into 2G over 118.887. From this we are getting the relation V1 is square root of 2.475. From that, by square rooting this, we are getting V1 equal to 1.573 meter per second. By using this velocity, rate of flow, we have flow equation is A1 V1. So A1 is pi by 4 d1 square and V1 is 1.573. So by using this d1 is 0.3, that is square, 0.2 square, into V1 is 1.573. By using this calculation, we are getting 0.1111132 meter cube per second. Meter cube converted as liters is multiplied by 1000 gives 111.13 liters per second approximately. Now we are considering neglecting minor losses. Neglecting minor losses is, that is at entrance, at end contraction, we are not considering those values, only we are considering frictional losses. H equal, that is total head loss is 4F1 L1 V1 squared by D1 2G for the second pipe, this is for the third pipe. Comparing F1 V1 in terms of V2 and V3, we are using this V1 squared by 2G, we are using those values, that is for F1 L1, that is V1 is common, and for that we are using V1 is in terms V2 and V3 is in terms of V1, we are getting these values. Now this 15 equal V1 squared by 2G. These calculations are having 20 plus 89.505, 3.189, adding all 111.694. So we are having that V square equal 2.6349. By using square root, we are getting 1.623, that is velocity in the pipe 1. So discharge Q equal to A1 V1, continuous equation, that is we are using the cross-sectional area and finding we are getting discharge is nearly about 114.7 liter per second. Here considering losses, we are having 111.13 liters per second. If considering you are leaving minor losses, only major losses we are considering, this little changes, little increase, that is here 111.13 and that 114.7 liters per second. So far we have done flow through compound pipes, that pipes are in series we consider, and from that we are using one example problem, we solved it. We have done. Please subscribe our YouTube channel.